We're going to focus today on quadratic functions. When you graph a quadratic function, you get a horseshoe shape. We call that a parabola. All quadratic functions have that basic shape. There's really three forms that you can have your quadratic function in. Kind of the standard form with no parentheses. You can have it factored into two identical or two parentheses. We've done the factoring before. Or you can have what's referred to as the vertex form. We're going to go ahead and find the zero. The zeros are when your y value is 0. So to find your zeros, you set equal to 0. So in other words, if you had this first one set equal to a 0 here, you could just go ahead and use your quadratic formula on it. In that case, your vertex, where it changes from going down to going up, is at negative b over 2a. That's halfway in between the two roots that you would get from your quadratic formula. Well, how do you get the y-coordinate? Well, basically you plug it in. And this is mathematical notation that says you find the y-coordinate, you plug in your x value. Well, this one here, if you were setting that one equal to 0, you could just go ahead and get the squared term by itself by getting rid of the k by subtracting a k, getting rid of the a by dividing, and then taking your square root and continue to get x by itself. Your vertex in this form is the opposite of what's in the parentheses and the same as what's afterwards. Over here in the far right, in your factored form, if you were asked to solve that, you'd set it equal to 0. Well, when you set it equal to 0, you'd then have your two parentheses multiplied together times a number in front. So basically, you're going to just set each factor equal to 0. And that's what we're talking about here. So when you set the first one equal to 0, you would get a x sub 1. You set the second one equal to 0, you get an x sub 2. And just like we said over here, your vertex is halfway in between your two zeros. And that's what we're saying here. It's halfway in between. Halfway is your average. So you're going to add these, divide by 2. And then just like we said over here, to find your y-coordinate, you got to just plug that in. And while that's the mathematical notation, it says to find your y-coordinate, plug in this x value. If a, the number in front of your squared term, is positive, it opens up. And if it opens up, it has a bottom point and it would have a minimum. However, if your a in front is negative, it opens down and it has a top point. So it would have a maximum. Now, your x-coordinate of your vertex tells you when your max or min occurs, how far you have to go left and right to find your max or min. But it's really the y-coordinate that tells you what your maximum or minimum is. Your max or min is the height, how high it goes here, or how low it goes here, and that's always the y-coordinate. So as we take a look here, we need to go ahead and get this in the standard vertex form. We're starting out with the standard form, so you need to complete the square. To complete the square, you need to have a 1 in front of your squared term, so you're going to factor negative 4 only out of the x's. We're going to leave our negative 13 out back. So we're going to leave that negative 4 there. Complete the square, so you got to take half of your 4 here in front of the x of the first and square it. And then you got to still have your minus 13. But if we added something here, then we got to undo that by subtracting it. And it's really, in this case, you'll notice a negative 4 times that. So we really got to subtract that negative 4 times what we added. Well, then it does factor into two identical parentheses out back here. It simplifies down to a 3. Now it's in the standard vertex form. So your vertex is always the opposite of the parentheses, same as the outside. Now you need to go ahead and find your zeros. Well, one way to find your zeros of this problem here, since it's in standard form, would be using your quadratic formula, which we've done before. A is always in front of your squared term, the negative 4. B is always in front of your term to the first power, which is 16. C is always the one that has no variables. So we'll just plug that into our quadratic formula. Simplify what's inside of your root. You'll notice you have the square root of 48. That simplifies. It's not a perfect square, but it does have factors that are a perfect square. And so now you can take the square root of the 16, which is your 4. Can't do anything with the square root of the 3, so we leave that. So now we could write it as a couple separate fractions. This simplifies down, and then this simplifies down. And so there's your answer. Now, it could also have been done using your vertex form that we transformed it into over here on the left. So to do that, to solve it, I would subtract my 3, get rid of the negative 4 by dividing by negative 4, get rid of my squaring by taking the square root of both sides. Notice the square root of the left side, square root of the top, square root of the bottom. Now we'd have to go ahead and add 2. Hey, lo and behold, we got the same answer we did up here. But that's good because it's the same problem, just worked out in 2 different ways. So we should get the same answer. But either way works. Now, when you looked at your problem that we started out with, would it have a maximum or a minimum? Well, we knew our A value was negative, so it opened down, so therefore you would have a maximum. What is the maximum? Remember, if you're looking for the max or min, that's the y-coordinate of your vertex, so our maximum is 3. When does it have a maximum or minimum? Remember we said that was your x-coordinate, tells you when it occurs, so it occurs when x is 2. Well, here you're asked to find the equation of a parabola. You're given your vertex, so I'm going to start with my vertex form. Because no matter which form you started out with, the standard form, you'd have to find a, b, and c. Or your factored form, you'd have to find your a, your x sub 1, or your x sub 2. Or your vertex form, you still have to find 3 things. However, I like the idea of using my vertex form. Since I'm giving my vertex, I automatically know my h and my k, which means I automatically, right away, know 2 of my 3 unknowns. All I have to do now is to find a. Well, I'm given this other piece of information, my x-intercept being negative 4, but that's really a point, negative 4 and 0. That's really an x and a y. So I'm going to take my negative 4 and plug it in for x, my 0, plug it in for y. 0 and for y, my negative 4 and for x. And now I have one equation where I don't know a, so all I have to do is just plug that in. Solving it for a, take my 7 to the other side, go ahead and divide. All I have to do at this point is to go ahead and rewrite this right here, but replace the a with my 7 over 64. And therefore I have my equation of my parabola.